Hi, I'm Jeff Hulett, CTO at Vektrex, and I'm the architect for the SpikeSafe series of current sources. They're used worldwide in reliability, LM80, and other photometric testing applications. Today I'm going to talk to you about repeatability, which is the third step for improved LED light measurements. Well, what drives repeatability? Here's a measurement on the left side showing 500 repeated light measurements, and you can see quite a bit of variation, actually 0.6%. And if we start to look at what drives that, the traditional sources that people are used to for incandescent lighting, like current stability and spectrometer stability, aren't really driving these differences. What is, though, is timing stability. And that's because the measurements are made as the LED is heating dynamically, and when you make the measurement, it makes a big difference in what kind of measurement you get. So first, let's look at the DC and single pulse methods from LM85. For DC and single pulse, the light and voltage capture is started after a delay. This means that if the delay varies, the actual heating in the LED varies. That's what's shown in this slide. On the left, you can see a measurement with a 5 millisecond delay that has about 15 degrees of junction heating. The same measurement made after a 15 millisecond delay has 17 degrees of junction heating. 2 degrees may not seem like a lot, but it is a lot in terms of the variability that LEDs have. It means a 0.4% variation in flux. Here's an example repetitive single pulse measurement using a Keithley 2401 current source. And this current source has some timing variation. And you can see we have 0.4% variation right here. Sometimes the measurements are as much as 0.4% off the trend line. And if we look closer at that source and actually look at the timing of the current pulses themselves, you'll see that the current pulse that's being used to measure the LED is varying 42% in its width. So this is confirming that that timing variation is what's driving that measurement variation. Taking the same LED and measuring it with the SpikeSafe 400 current source that has precision timing, it only has a 0.03% measurement deviation, and that's consistent with the deviation of the spectrometer itself. So we have no timing-based measurement deviation. Now let's look at the continuous pulse method. The continuous pulse method is a little different because the current transitions up and down during the integration time. And this means that the actual measurement must be multiplied by a factor in order to obtain the actual flux value. The factor is equal to the light off time plus the on time, the entire measurement time, divided by the light on time. So you can see by this equation that if your pulse on time or light on time varies, the actual factor needs to vary also. So looking at current sources, all current sources typically have what's called a jitter specification, which is the amount that their pulse can vary in width. For example, the Keithley 2600 current source can vary in width up to 2 microseconds for a pulse. The National Instruments 1 microsecond, and the Vektrex current source 0.03 microseconds. These jitter specs can be calculated with the pulse width, and you can calculate exactly how much of a luminary you can expect. And you can see at narrower pulse widths towards 100 microseconds, you get large errors with a couple of these sources, up to 2%. So those kinds of jitter errors will drive you crazy, especially if you're trying to make long-term trend measurements. For example, for an LM80 test where you're doing analysis of trends, you really want the very least amount of jitter and variation in your measurements possible. So to summarize, with the LM85 test methods, you need 2 different schemes to reduce your errors and improve your repeatability. For DC and single pulse, improve your trigger timing. For continuous pulse, reduce your pulse width jitter. Thank you very much for watching the final segment of our webinar series on improving LED light measurements. Go to Vektrex.com for more information about the SpikeSafe Performance Precision Pulsed Current Sources.